So that is the reason why I had asked you to try that. Yeah. Any other queries or questions? Okay, I have a query of y'all to ask of y'all. Do you need to write down instructions, or would you remember them once told to you? Yeah. Do you all need to write down instructions, or do you remember them once if you're told instructions, you follow them? Just wanted to understand from you all. Because one of the instructions told to you all is that you all need to switch on your cameras, right? So I don't know whether you need to write that down. Right. If you need to write it down, please write it down. When I log on to the session, I will switch on my camera. If you don't remember that, then you can do it right now. Okay, switching on the camera has two effects. First is, you know that you're being watched, so you're naturally more attentive. And it also helps me gauge your reactions. From your face, I can know whether you're following me or not, or whether it has gone somewhere else. So, anyway, so please keep your cameras on. All right. The last example that we had taken up was, lambdas. Did we try lambdas? I don't remember. I'm asking you. Did we try lambdas?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So that was the last thing that we have taken. We're going to try out today a few things that we can do with delegates. Okay. So we have seen how you can write delegates, how you can have anonymous functions, lambdas. Let's see a few, practical applications of delegates. But before we get into a practical application of a delegate, I would like to talk about one aspect of our code out here and discuss this aspect and, then go ahead with the example. So typically, when you're writing code out here, you're actually performing three roles, right? For example, what you're doing first is you're creating a class. Right? You're creating a class. Then somewhere later in your code, you're creating an object of the class. And somewhere in there, I'm not writing the whole static void main, but somewhere in the main out there, what are we doing here? We are creating an object of that class. So let's say if I'm doing a class 1 O is equal to new class 1. Okay, this is what you're doing later in your code. Then you run your code, right? And when you run your code, you see the output window. So this is where you're seeing the output. Currently, you're seeing it where? Where are you seeing the output window currently?
Command prompt.
In a console application. Okay. So you would be seeing different types of projects. Like, for example, instead of a console application, you could be creating a web application and the output would be then shown in a browser. Or if you're creating a Windows application, a desktop application, then the output would be shown in a window, like you'd be creating out there. So you're not seeing these different types of applications, but you could have output in different formats based on the type of application that you're creating. Okay. Now, my problem with y'all is that y'all don't consider yourself as three different people. In your mind, you're one person. But actually, when you do these three different things, you are three different people. Let me explain what I mean. Supposing I write this class, I, Vikram, all right? I write this class, right? And I give you my class. And you create an object. You create an object of the class. So you're creating some software, you're creating an object of my class. And you finish writing your code and you sell it to the client. Sell your software to the client. And now, who would be running the code, would be seeing the output out there and whatnot, would not be you, but would be the client, would be the third person out here. So there are three people involved here. First one is the developer of the class. The second one here is whom I call as the user of the class. The user of this class is the one who's creating an object of this class. And the third person whom I'm calling here is the end user. End user, the one who's actually seeing the output. And these, as I said earlier, are three different individuals, three different entities. But when you write code, you don't consider them different. You end up writing code, you mix and match something. So for you, right, whether you write code here or whether you write code here, whether you write it as a developer or as a user, for you, it doesn't make a difference because you're saying anyway, my code is running, I can see the output. But there is a difference, right? So here I want to just illustrate the difference. Now, for example, let's take this situation where the developer is Vikram, the user is all of you all individually, and the end user is someone else who is selling the software, right? Now, when I create my class, when Vikram creates his class, does Vikram know about the end user? Who the end user is going to be? When the developer creates his class, would he know in what way is his class going to be used? Let's say I create an employee class. Now, where can you be using this class? You can be creating a console application. You could be creating a Windows application. You could be creating a web application. So will me, the class developer, know where my class is being used by you, the user? Yes or no?
No, sir.
No, sir.
Will the user know who's the end user? Will the user know who's the end user? What type of end user is going to be there? What should be shown to the end user? Would the user know that? Yes or no?
So he may have a basic idea, but not exactly.
He may not know, the individual using it, but he will know in what context he is using it. He will know he's creating a console app, or he will know that he is creating a Windows app. And this is how the end user will work with his application. So he will know that well. When he's writing code, when the user is writing code, he knows that, okay, this is how the code is going to appear to the end user. He may not know the name of the end user, but he will know in what context the end user is going to use it. So the user can communicate with the end user effectively. But the developer should not be communicating with the end user. The developer should not be communicating with the end user. Because why? Why should the developer not be communicating with the end user? Yes.
So it's not his concern.
He may not know who the end user is. He may not, first thing is, he may not know who the end user is. Secondly, supposing I am giving my class to 5 of you all. You might want to use my class differently. The way one of you uses the class would be different from the way in which somebody else is using this class. Now, if I am forcing you to use some particular code, and if the developer is trying to talk to the end user, I'm taking that away from you, the user. The user is not able to then put in his own code if the developer has put in the code. So conceptually, conceptually, I'm saying that the developer should only be communicating with whom? With the user. And the user should be communicating with the end user. And the developer should not be communicating with the end user. Are we clear on this, everybody? But in your mind, that doesn't happen. In your mind, you all tend to mix up concepts. That is where my issue is. So I'm asking you to think this differently. Okay. Now the question comes up when the developer has to communicate to the end user. How can he communicate to the end user? Not end user, to the user. How can he communicate to the user? How will he do that? So the developer wants to inform the user that something has happened. And then based on whatever has happened, the user may or may not take action, may want to take action based on it. So now what are we trying to look at? We're trying to look at the communication between developer and user. Now there are two situations, two major situations that you will use. In one situation is the developer says that something critical has happened. Something has gone wrong, drastically wrong. And I want the user to take some action on this. Without taking action, the user should not be allowed to carry on in his code. So that is one situation where the developer might want to inform the user. First is a critical situation. Critical meaning what? Something has gone wrong in the code. And I don't want the user to continue working until this is solved. In such a situation, the developer will throw an exception. Now, when he throws an exception, the user is forced to do what?
Handle the exception.
Handle the exception. And unless he handles the exception, he cannot carry on. His code crashes. His program terminates. So that is one way for the developer to talk to the user, by throwing an exception. In what situations would you throw an exception? When something critical has happened, something has gone wrong in your code. Are we clear on this, everybody? Now there exists the second situation where the developer only wants to inform the user that something has happened. There is some change of state. All right? Something has happened in my code, but it is not critical. So I just want to inform you that there is a change of state, but I don't want to force you to take some action. You may or may not take any action. Whom is he telling this? He's telling the user that I want to tell you that something about this. But now whether you do something about it or not is your concern. All right? This should be a non-critical way of informing him that something has happened. Right? And the non-critical way of informing him something was happening is by raising an event. Okay. So we're going to look at both these things today. The first one that we're going to see is critical way. Something that you have already done before. Throwing an exception and handling the exception. Okay. That's the first thing that we'll look at. The second thing that we'll look at is how do you inform the user that something has happened in a non-critical way? And that's when we will discuss events. Okay. So if you were to discuss exception handling first, exception handling again is at two levels. The developer, the person who's creating the class, would be throwing an exception, and the person who's creating an object of that class, so the person who's using that class, would be handling the exception using a try catch. Let's first write down the code for the user. What if there is an existing code throwing an exception? How does the user handle this? Now, this is going to be very, very similar to what you have done in Java. There will be a lot of similarities. So this is a topic that you all are already knowing. You all should not be, these should not be new concepts to you all. So I would expect a lot of responses from you. All right. Later we'll look at events. Any questions before we begin? We're going to go into the code now. Anything that you'd like to ask before we begin?
So
Yes.
So what exactly indicates that developer is directly communicating to end user? I mean, what code will indicate that it will?
I'll show you. I'll show you a code snippet.
Okay,
I'll show
sir.
you something that we've been doing since day 1 or day 2, and which we should not have been doing. Okay. And I don't blame you, because I was the one who told you write code like this. So me and whoever else has taught you whatever would have been telling you this. So let's look at this. What day are we on? What are the last? Today is what day?
7th day, sir.
7th day today. Okay. So day 7 is what I'm calling it. And let's start with exception handling. All right. I am going to copy paste some code and get it working, or to just help me speed up on the code. I'm going to borrow from my existing example. So just give me a minute while I copy that code. All right, so I'm ready to resume. Look at this code snippet. I have a public class 1, which has one property, which is P1. All right. There is some code in there. Return P1 equal to value. Let's see this code. Right. Okay. I'm in main. I have written some code snippet, and I'd like you to go through the code snippet. And you would have faced this. A lot of you all in your lab example had a Stack Overflow exception. So you would have faced some exception at some point of time or the other, and you have seen at least what is happening. Some of you have written flawless code, have not seen any exceptions happening, which is great. But most of you all at some point have faced some exceptions. So in this code, I have purposely sort of written code to possibly throw exceptions. What possible exceptions or what possible things could go wrong in my code? Can you identify what could go wrong?
Null pointer exception.
Null pointer.
Tell me line number first and tell me what is going wrong.
Line number 42.
42, sir.
42,
Line number
yes.
41, sir.
42. Okay, somebody said 42. Give me, there are multiple exceptions. So what's wrong on 42?
Arithmetic exception.
Null pointer.
Null point exception.
Null pointer or null reference exception. Okay, somebody said 41. What could go wrong on 41?
So number format exception, as in we gave wrong input.
Right.
X
What if
will
you
be-
don't enter a number? Then while converting it will give you a problem.
And if you enter
Also-
the number 0, then it will be show exception.
Yeah, so that's one of my favorite exceptions, the divide by 0 exception, if you enter a
Yes, sir.
0, right? So let's see what is happening here. Let's illustrate this. Let's start with line 41 and we'll see all the exceptions that are happening here. So if you look at line 41, and if I enter a non-number, this gives me a format exception. Now you can understand what all information is being presented to you here. System.format exception. This is the exception that was being thrown. This was the error message which said input string was not in the correct format. Okay. Now we'll go into these details in a minute, or let's see it now only. If you go into view details, it shows you more details about this exception. So it shows you more details about the exception, and I'll come back and talk about these properties. Right? I'll explain to you what these properties mean. But this was one exception that you had. Okay. Second possible exception is if I enter a number 0, then on line 42, it gave you a divide by 0 exception. Attempted to divide by 0. That was the second possibility out here. Right? So this was another exception that was being generated. Third possibility, if I enter a valid number, let's say I enter 10, then 100 divided by 10 is 10. But if I tried assigning it to O.P1, it gives you a null reference exception. The name of the exception here is null reference exception. And object instance not set to an object reference not set to an instance of an object. Now, all these exceptions that you saw, right? All these exceptions that you saw were inheriting from the exception class. The exception class is the base class of all exceptions, either directly or indirectly. I'll explain what I mean by directly or indirectly. Under the exception class, there are two other classes, one called system exception and one called application exception. The system exception is the base class for all .NET related exceptions. So all inbuilt exceptions that .NET has created, all of these inherit from system exception. So all of these, which ones did we see right now? We saw a format exception, a null reference exception, and a divide by 0 exception. All of these are inheriting from system exception in some way. Application exception, on the other hand, is meant for any exception classes that you create. So if you're creating your own exception classes, it is suggested that you inherit from application exception. So these are the custom exceptions that are being created. All right. System exception had multiple exceptions. One of them was null reference exception. I'm writing it in short. Okay. Actual name is what? Null reference exception. It's too big to fit here. Another one that we saw was format exception that we just saw in our code. Another one was divide by 0 exception, but the divide by 0 exception actually inherits from the arithmetic exception class. So the arithmetic exception class is the base class for other arithmetic related exceptions, one of which is divide by 0 exception. Now there are hundreds of such classes, exception classes, inbuilt classes. And if you wanted to read up more on them, you'll have to consult the documentation where you could, see what are the different exception classes that are there in .NET. But as and when you encounter them, then do read up on them. So this is, part of the hierarchy that you saw from the classes that we just experienced. Okay. Now the exception class has certain common properties defined. And these properties help you find out information about the exception that has occurred. So these properties that have been defined in the exception class obviously will be available to all your derived classes. And let's see what some of these properties are. All right. So let's go into the code again. And let me give in a wrong value. One of the exceptions that occurred was format exception. Let's go into view details. And view details actually shows the properties of the exception class. One of the properties there is the message property. Right? It's too small for me to read, so I'm just pasting it here. The message property, what did that give you? What did that give you? What does the message property tell you? Yes?
That input was not in correct format.
The error message.
Cause
which is
of
shown.
except cause of
The error message that is shown when that exception occurs. Why did the exception occur? Okay. So that is the message property. The second important property here is the source. The source is the name of the assembly in which the exception occurred. So what is source here? Source is the name of the assembly in which the exception occurred. All right. The assembly being used is MS core lib. This is one of the main .NET assemblies. Most of the code in .NET is actually in this MS core lib library. Okay. Third thing is the target site. So target site is the name of the function in which the exception occurred. What are the name of the function in which the exception occurred? Here in this case, what is the name of the function? String to number. And which is actually having these parameters, and it is available in this namespace out here. So this is where it's actually occurring. This is the name of the function. Target site gives you function name. But we didn't call string to number, did we? Did we call string to number? In our code, what have I called? What have I called in my code? What have I called actually?
Console.readline?
No. Console.readline took the input, but that was passed as a parameter to convert.toInt32. So the function that is causing the error is convert.toInt32, which is taking a string as the parameter. You called console.readline, that worked correctly. But when console.readline was passed to convert.toInt32, that's when the error occurred.
Yes, sir.
Now, how did it get to, what did we say? Target site is what? String to number. So how did it get to string to number? That will be shown to you in the stack trace. So stack trace were the functions that were available on the stack when the exception occurred. If you go back to my code, what is the first function that ran in my code? What is the first function that ran?
Main.
Main. Now main went and called which one? Main went and called what? Convert.toInt32. So let's see this. The first thing that ran, now if it's a stack, it will always be in the reverse order. Okay. Stack trace is showing you the stack. So it's always in the reverse order. So first function that ran was main. Main went and called convert.toInt32. Convert.toInt32 went and called number.passInt32. And number.passInt32 went and called string to number. Number.string to number. So internally, this is how the functions got called. And what are the target site? Which is the function that gave an error? Was string to number. Now this helps you understand how did the code run to the point where it gave you that exception. So supposing in your code, you called function A. Now A went and called B. B went and called C. C went and called D. And somewhere in there, the error has come. So stack trace will help you identify whether the error was in A or whether it was in B, or whether in C or in D. So that will help you identify where the exception is. So all of this information is useful to debug where the exception is occurring, and then you can go and try and identify that. You know, when you all might have experienced that in the lab. Some of you will just come and tell me, sir, error. I said, okay, what is the error? My code is the error, sir. I said, which line of code is giving the error? I don't know, sir. Somewhere when I run it is giving the error. These are the answers that I'm getting. So then what I asked you to do, some of you would have experienced this. I tell you, comment out all other code which is not giving an error. Then identify those 3-4 lines which is giving an error. And then debug. Okay, this function calls this function. This function calls this function. This line gave an error. So all of this information is useful in that debugging process. Sorry to say, but your debugging skills are lacking. If you all get an error, you all say, sir, error. That is your way of debugging. You raise your hand and say, sir, error. You should be able to, as a programmer, be able to figure out why is the error occurring, and then use your previous knowledge to try and solve the error. That is how you approach it. So all of this information is being given to you in view details, is giving you details about that. There's one more property right now which is null called inner exception. Inner exception would be used in certain cases where there is an outer exception and the inner exception. So the outer exception might be a very general exception, and the inner exception will be a more specific reason why the error occurred. Like for example, if you're working with databases, the outer exception might be a database exception, and the inner exception might contain information about what specific action you are doing, which is in the database, which is causing the exception to occur. So right now this is null because this is a very simple exception, but you can have an inner exception which again gives you information about what the exception is. And the inner exception is also an exception type. So what properties will the inner exception again have? Again, similar properties, property like message, properties like, stack trace or whatever else that is there. So these are the 5 properties that will help you identify and isolate and debug errors. Message. What is message? Quick. This is the simplest of the property. What is this?
It is telling why the error is
Cause of
occurring.
exception.
The reason why the exception occurred. It describes why the exception occurs. Source.
In which assembly exception is occurred.
Assembly name where the exception occurred. Target side.
Name of the function.
Name the function where the exception occurred. Stack trace.
Address. To
The complete
what were the
function
functions
in the stack.
on the stack when the exception occurred?
Yes.
And finally, inner exception would be used. Mostly it will be null. Sometimes it will not be null. Will be the real reason why the exception occurred. So the outer exception might contain, overall reason, but the specific reason why the exception occurred could come in inner exception. So when they're not null, read details about that. Are we clear on this?
Sir, can you explain inner exception?
I gave you the example of a database. So let's say in the database, you're calling a stored procedure, and the stored procedure is writing, let's say, an insert statement, and the insert statement is causing, let's say, a foreign key constraint. Now, the outer exception could say that it's a database exception, but the inner exception will tell you the real reason that to the foreign key constraint being violated. So you might have situations like that. Okay.
Thank you, sir.
All right. So let's come back into the code out here. When I'm writing code like this, am I right now, am I the developer or am I the user?
Developer, user, sir.
What class am I using that is causing a problem? Which class in my code here, which class am I using that is causing a problem?
Class 1.
On line 41, what is the class that I'm using?
Convert.
Convert. On line 42, what class am I using?
Class.
Class 1.
Class 1. Are we getting this? So that's what is causing a problem. So right now I'm in the role of a user. Remember, whenever you're using main, typically that's when you're creating an object of some class. That's where you're thinking like a user. So now convert through an exception saying that I cannot convert this. So you better handle this. Otherwise your code will crash. Right? And now we need to handle that exception. And this is where you all know this code. The code, I have no problem with you all about the code part. You all know the code. But why to write, when to write, where to write, I do have a problem with that. So let's have a look at this. Let's put in a try catch block out here. Okay, again, I'm simplifying things by just copy pasting my code out here. So the same code, I could now make sure that it does not give me an exception by giving a try catch block. Right? By giving a try catch block. So I put that code into a try and I put a catch out here. If no exceptions occurred, if these lines did not give any error, then it will complete the entire try block and jump to the statement after the catch block. It will not execute the catch block at all if there were no exceptions in your code. Right? Let's try this. Let's try this. So I'm not doing obj equal to null and I enter a correct value. It goes into no exceptions and the code in the catch does not occur. So where will it jump to after that? It will directly jump to the code after catch. But if there were exceptions, supposing this line gave an exception, line 53 gave an exception. From line 53, it will jump to the catch block and the first available block which can handle the exception, it will go into that block. Right now I have only one block. So it will go into this catch and just shows me exception. After it completes the catch block, it will not go back to the other lines out here. So if line number 53 gave an exception, it's onto the catch block, finish the catch block, and then continue with the code after the catch block. Right? If line number 54 gave an exception, then similarly, it will jump to the catch block, complete the code in catch block, not execute 55, 56, and come out of there. So this is how the catch block would work. Let's try this. So let's try an exception. Exception occurred. This was, which one was this? Which exception is occurring right now?
Format exception.
Format exception.
All right. What if I enter 0? Which exception is occurring?
Exception.
Divide by 0.
0 exception, which is on line number 54. From there, it jumps into the exception block, into the catch block. And if everything was entered correctly, then what is happening?
Null exception.
Null left in the exception, which is again on line number 54. So this is again causing a problem. Now here it shows you this message because of this option here. What is it showing? What is this option showing? What does this say? Break when the exception is thrown. All right. And you can change it. If you remove it, it will not show up. And if I continue with F5, then it continues with the code. So it just as a developer, it's just showing me that this is what is happening. But the code, when you're not running it in Visual Studio, then it will not, obviously it will not break, but it's continuing with the catch code out. Now, in all of this, when I added a catch block, what happened was my code didn't crash. My program continued execution. So I handled the exception. But what is the problem in this type of catch block? Why is this catch block not ideal? What is the issue in this? Can you see, identify what could be the problem here? Okay, why am I saying that, we can improve on this? What is the problem?
Not showing the proper exception.
Correct. So you don't know firstly which exception occurred. And if you wanted to write different code for different exceptions, this catch block is of no use. This catch block is okay if you wanted to write common code for all exceptions. But if you wanted to write different code for different exceptions, then you need separate catch blocks. So let's see this example here. And in this example, instead of writing one catch block, I have multiple catch blocks. Which are these catch blocks now? One for divide by zero exception, one for null reference exception, one for format exception. Now, if the divide by zero exception occurred, it will go into this catch block. It will complete the code for this catch block, and it will jump to outside the catch blocks. It won't check the others. It won't check the others. If a format exception occurred, then it will first try to go into this catch block. But format exception cannot be handled by divide by zero. So it will go into the next one. It will try to see whether it can be caught in the next catch block. If it cannot be caught in the next catch block, it will try to the next one. And in this case, what will it do? It will go into this catch block, run the code, and then complete the code out of it, come out of there. What if this was not there? What if format exception was not, catch block was not there? Then what will it do now in this case? If a format exception did occur, what will it do?
Code will terminate abruptly.
Sorry, say that again.
Code will get terminated abruptly.
Correct. So your program, it's like not handling it at all. Since you're not handling it, program will terminate at this point. So that's what we have tried out here, multiple catch blocks. And based on the exception that occurs, one of the catch blocks should be executed. So format exception, right? Or divide by zero exception, or if everything else was correct, then null reference exception. All right, that is what is being shown here. All right, so this is what you could do by writing multiple catch blocks. I'm going a little quick in this because you have done this before. If you have a query, then ask. Otherwise, I'm presuming that you already know this. All right. Now, while catching an exception, you can catch it with either that class or any of its base classes. So for example, here, if I take you back to this hierarchy, what is the base class of divide by zero exception?
Arithmetic
Arithmetic exception. Base class of arithmetic exception was
System exception.
System exception.
And base class of that was the exception. All right. How do you confirm that? If you just go to the exception class, it says it inherits from arithmetic exception. Arithmetic exception inherits from system exception, and system exception inherits from exception. So you can go into the help and see what is the hierarchy. So while catching it, I can either catch it as divide by zero exception, or I could also catch it as arithmetic exception. So even this code works. All right, let's try running this. 0, and the divide by zero exception now is being caught by whom? By arithmetic exception. Could also have been caught by
System exception.
System exception. So this also would catch divide by zero exception. But while doing this, you need to be careful. For example, format exception can be caught by whom? Format exception, what's the base class?
System exception.
If I try doing this for format exception, this line gives me an error in my code, compilation error. And the reason for the error is because now this code is not reachable. The null reference exception can be also caught by system exception. So if it's going to go sequentially, then this code block will never be reached. Similarly, divide by zero exception can be caught by system exception. So you won't get this code block being reached. So the thumb rule is when you are giving this, the base class exception has to be caught after the derived class exceptions. And that is okay, which is why, when you gave system exception here at the end, it worked fine. Because format exception, null reference exception are now being caught before the system exception. So that's one thing that you need to be aware of. All right. The exception class is the base class of all exceptions, either directly or indirectly. So therefore, when you say catch exception EX, what will this catch? What will this catch now?
All type of exceptions.
All type of exception.
All types of exceptions which have not been handled before. If they've been handled before, then they'll be caught in that block. Otherwise, everything else can be caught out. And how do you know details about which exceptions are occurring? All of these properties that we saw some time back, those could help you. So ex.message, for example, exception EX, and ex.message or other details would give you details about it. Right. Questions, if any? Again, as I said, these are concepts that you have done before and should be fairly easy for you.
So when we are mentioning exception in the catch block, I mean the base class exception, and when we are not mentioning the type of exception. So
Then
are
you
these
won't
two
get the
catch
problem.
are these two catch blocks different or same? The first catch block
They're slightly different, because if in this case I also have an option of specifying exception EX, and EX will give me the properties of the exception, which you will not get with that simple catch block that we had at the beginning. So I'm able to now get details like ex.message, which I would not have got there in the other catch block. But other than that, they're both similar. So they will catch all exceptions.
So sir, what if I want to print the message in that catch block?
You can't.
Okay.
You can't. Which is why you need to do this.
Okay.
That is a very simplistic thing. It says that, if an exception is occurring, ignore the exception. That is what essentially that is. But any additional, fine tuning that you want, then you'll have to do something like this.
Okay.
All right. In the next example, I have a nested. Okay, before I do that, I needed to show you one more. Yes. Okay, this is not a nested try block actually. I wanted to show you a finally block, and I missed out on, I copy pasted the wrong one. Okay. Finally is an option that you can give with every try block, and the code in finally will run in all these situations. First possibility is when the exception does not occur, even then the code in finally would run. Second possibility is if an exception occurs and is handled, even then the code in finally would run. The third possibility is when an exception occurs and the code is not handled, even then the code in finally would run. All right. So if you're looking at this code for finally, let's try out options. What if there were no exceptions? All right. So what if there were no exceptions? I'm given a valid value. Oh, I'm so sorry. I should have kept it as this. I commented, uncommented by mistake. No exceptions and code and finally ran. if an exception did occur, let's say 0, divide by the 0 exception followed by finally. The possibility is if your exception occurred but was not handled, even then the finally would run. I'm not running that. For that, you need to run it outside Visual Studio, not within Visual Studio. Run it separately by itself, not from within Visual Studio. Now, in these cases, why are we writing a finally? If you're writing some code which is common code that should run whether an exception occurs or not, such code can be written in finally. A typical example given for a finally is, let's assume you are working with a database. So you managed to open the connection correctly. After opening the connection, now you're trying to run some command on the database. While running the command, two possibilities exist. Either the command might work and there are no exceptions, or second possibility, the command might not work and there might be an exception occurring. Now, in both these cases, irrespective of whether the command worked or not, at the end of the code, I would like to close my connection. So that could be a good example of where you could be using a finally. Right? Another place where you could need a finally is if you had a function that was returning values. So in my function, let's assume I had some code like this. Right? I'm saying if some condition, let's say okay, let's say this is the code that I had out here. Okay. Now within this code, if an exception occurs, right? Within this code, if an exception occurs, if you'd like to run some common code, or let me put it this way, let me make it a little better. Let's assume I had code like this. Okay. Now supposing some exception occurred. Okay, supposing some exception occurred. And the exception occurred on this line of code. Right? Supposing the exception occurred on this line of code, then the remaining part of the code would not work. Now, if you could put this code in a try, okay, if you put this code in a try, and you write this code, let's say there was a catch also, and you put this code by itself. You put what? Store X into database by itself. This code will not run if an exception occurs. All right. But if you put this code in a finally, right, then this code will also run if the exception happened. So A, let's call this A. And let's call this B. All right. I'm saying A will occur on, even if whether an exception occurs or doesn't occur, A will definitely happen. But B will happen only when will B only happen?
When it is handled.
No exception.
When no exception occurs. Are we clear on this, everybody? So this is what I'm trying to show you out here. So if you are having a return statement from a function, there also the finally comes into play. So code after the exception handling block, need not necessarily run, but code in finally will always run. So this is what I was just trying to illustrate out here. So that's your finally code. That's how you would work with finally. Okay, so we just ran this and we saw how finally worked. Typically, common code that you like to write at the end of your code block, and that should run whether the exception occurred or not, could be put into finally. All right, let's try a nested try block. In a nested try block, you could have a try within a try or a try within a catch. So if I got a try out here, I'm saying I'm trying to run this code. If a format exception occurs, I'm going to try to run some other code again. So I got a try here within this outer try. Now each of the tries would have its own catch blocks. And each of the tries could have their own finally block as well. So for example, if no exceptions occurred, then what will happen? How will the code run? If there were no exceptions, then no exceptions followed by what?
Directly it go.
Followed by what?
In
Try
finally
first
blocks,
try
sir.
and direct finally.
The outer finally. Okay. But if an exception occurred, and let's say it was a format exception, then after this code, it will jump into the code for this. If no exceptions occurred, then the code for finally would run. If an exception occurred, then the code for catch, followed by this code. And then after it has finished this part of the code, it will go and execute the outer finally also. So the point I'm making is that you could have your, a set of catches or a set of finallys for each try, and you could have nested tries within tries or tries within catches. Right. So try this code out. I'm not running all possibilities. Let's try one example with no exceptions. So if no exceptions were encountered, only the outer finally ran. But if an exception occurred, let's say I gave a format exception. So format exception occurred, I'm accepting the value again. This time I don't give an exception. I don't make an exception. So what will happen now in this case? Firstly, the inner finally, following that, the outer finally. Okay. And if an exception did occur the second time round also, so let's say, enter only numbers, the wrong value is entered again. Now what? Firstly, the catch for that inner try, then the finally for the inner try, and then the outer finally would also run. All right. Try these out with different examples, and you can, take different situations and work with this.
So,
Yes.
so you said we can write nested try catch inside try or catch, right?
Yeah.
So
Yeah.
can't we write that in finally?
Yeah, you can.
Oh.
All right. Okay, few other things. When you write a try, every try must have
Catch block.
either it needs to have a catch block
Or finally.
Or finally.
or a
Finally.
finally. But one of the two is required. You can't just leave a try by itself. So you can do a try and a catch, or you can do a try and a finally, right? Or a try and a catch and a finally, whatever. But one of the two has to be given. Okay. Now, so far, we have been working with the code for the user. So we have been handling an exception that has been thrown by some other class. Okay, and that you do that with a try catch finally. Now we're going to go on to the other side, and we are saying, what if we are the developer? And instead of catching the exception, you're going to throw the exception. So you're going to start off by throwing the exception, and then whoever is using your class would be then forced to work with the, the try catch out. All right, so let me copy some code and get this ready. The example that I'm going to take up, the example that I'm going to take up is the code that we write while we validate a property. Okay, so I already have got this code functional, and just give me a minute while I remove all such traces of functionality. Let me not show you the finished output. I don't want to show you the finished output. Okay, I think I'm ready to show you this. All right, so look at the code in here. I made a slight change in my class code out here. So what is the thing that I have done differently from the previous example? What have I added extra?
So property that value should be less than 100.
So I put in the validation here, which says that value is less than 100. And if the value was not less than 100, what am I currently doing? What am I currently doing? Right now, what am I doing? I'm saying console.write. So when I create my class, when I create public class 1, what role am I performing right now? Right now, what role am I performing? Am I the developer or am I the user? Developer. You're creating a class. You're creating a class that's going to be used by other people. You're going to give this class to other people. They're going to create an object of your class. Now, when I write a console.write line, who's going to see this message? When I say console.write line, user won't see this message.
End user.
End user, sir.
I'm calling him the end user. So this message is meant for whom? The end user. Now, why did we say that this approach is wrong? Why did we say this approach is wrong? Right now, what is happening? Whom is the developer talking to?
End
He's talking
user.
to the end user. So why are we saying that this approach is wrong? There's nothing wrong in the syntax. Nothing wrong in the syntax. But there's something wrong in the basic concept, or way you're writing code is wrong.
So because user can't do anything, even if he gets it.
One possibility. So user doesn't know what to do now. Your developer is directly talking to him. The user is not able to pass on a message. First possibility. Any other possibility? Any other reason why this is fundamentally wrong?
So end user can't do anything about it.
Okay, it just my, I got two Wi-Fi networks. My one Wi-Fi network dropped and I got switched on to the other one. So can you all hear me clearly?
No, sir.
Can you all, am I still audible?
Right now you are, sir.
Yes,
Yes,
sir.
okay, okay. Yes, so what is the okay, so his voice is lagging for all. So that's what happened when my network switched. Okay, let me repeat the question. My question was, I heard what you all said, but for the benefit of those who could not hear me, why should I not do this? One reason that came to me was the fact that the developer is directly talking to him and the user can't put in his own messages. What is the second and more serious problem?
End user will not know P1 what is.
No,
So
that's not.
end user cannot do anything about it.
No. The second and more serious problem is the developer does not know what type of project the user is going to be using it in. So if I give it to you and you use it in a console app, then this is okay. But if you're going to be using it in a web application, then you cannot be putting a console.write line. The way in which you'll show a message in a web application will be totally different. Are you getting this, everybody? Let me try switching back to the other Wi-Fi. All right. So the point I'm making is that the end user, the application for the end user might be different. And I cannot be giving out messages like this. This, in fact, might cause my application to hang, might cause the user's application to hang if I'm giving out messages like this. So this is a far more serious problem. And to avoid this, what are we saying so far? That the developer should never try to communicate with the end user. Instead, the developer should communicate with the user in one of two ways. What are the two ways? Either critical or non-critical. Critical is you throw an exception and you force the user to put in a try-catch block and handle your exception. That will be the critical way. The other way we have not seen so far, which is using events. So this is what I'm going to do. I am not going to do this. In fact, from now on, don't ever do this. Instead, what am I going to do? I'm going to create the reverse of what I was doing so far. I was trying to catch an exception, right? We're trying to catch an exception. But now, instead of catching an exception, what are you going to do? What are you going to do? Throw the exception. So what were you catching? You were catching an object of the exception class, or it's one of the derived classes. We will throw the same thing. So let me create an object of the exception class, exception EX, right? And EX is equal to new exception. Let me do this, right? And throw EX. So I've thrown an object of the exception class. Now, when I go to catch it, where would I be catching it? Where would I write code for catching it? Who's going to do the try catch on this? Who's going to do the try catch?
User.
User. So which would be in class program, where he creates a main, he creates an object of that class, and he's written code like this. He's written code like this. So he said that if a format exception occurs, do this. If a null reference exception occurs, do this. And if an exception occurs, then do this. This is what he is doing. If an exception occurs, then do this. So right now I've just modified my code slightly. I'm not dividing it by 0. What am I doing? I'm saying obj.p1 equal to some value. Some value. If the value is more than 100, what is it going to do right now? If it is more than 100, what will it do?
Throw an exception.
Throw an exception. And that exception, if that value is more than 100, will be caught out here. Okay. And what will be shown here would be what? What will be shown here would be the error message. So let's try running this code. Firstly, we'll try running it with no exceptions. I'll enter a valid value. Valid value entered. What does it show me? Valid value entered. What does it show me? No exceptions. No problem. Right? Let me enter invalid value. So what if I enter 200 now? What is going to happen now? It's going to go into the else part. It's going to throw an exception, and that exception will be caught here in the catch. So look at this code. What does it show me? What error message does it show me? What is the error message shown? What is the default error message? Can you read it out for me?
Exception of the type system.exception was thrown.
Right. So it's giving a standard default message saying exception of this type was thrown. That is what is coming in the error message. But I don't want that. I don't want that. What I want to do is I want to give my own custom message. And this custom message, I will pass it to the user. Then what the user does is up to him. He can do it. He can display anything he wants out there. But I don't want to give this thing. I want to give a custom message. So instead of doing this code, the exception class has a message property. Correct?
Yes, sir.
Yes, sir.
So what I'm going to do here is I'm going to try to set the message property. ex.message is equal to invalid p1. Why am I trying to do this? So that my own exception message is shown out. But when I try doing this, it gives me an error saying that the message property cannot be assigned to, since it's a read-only property. So I can't assign it this way. I can't assign it this way. This one doesn't work. But the exception class has an overloaded constructor which takes what as the parameter? See this? What is it taking as a parameter?
Message.
Message. I can actually pass it here. Right? I can actually pass it here. Rather than the default message, I'm passing my own message. And if I now try running the code, now, what is the error message that would come up now? Earlier, what was coming up? An exception of type system.exception was thrown. That was the earlier message. Now what would come up? Would be
Invalid P1.
My message. So I can customize the message that I want this way. Are we clear on this, everybody? All right. Can we combine these two lines into one line? Can we combine these lines into one line? Right? What are we doing here? Throw new exception invalid P1. So this is just a shorter way of writing the earlier code. But you need to understand when you're saying new exception, you're actually creating an object of the exception class. So this is just a shorter way, and you've seen this way. You know how to do this. Now, I still have a problem with this way also. And the problem that I have with this way is my user, see, I'm the developer right now, but my user is forced to catch an exception as exception EX, which means now all my exceptions are going to be treated like any other exception. Now, what if I want him to be able to write different code for my specific exception? And instead of having to catch it as exception EX, I would like him to catch this as invalid P1 exception. I would like him to catch it in this way. What will be the advantage of doing this? What advantage does the user get from catching the exception in this manner?
Specific.
He's able to write specific code. So for example, in your employee class, if you had name, basic, department number, and what is that? Employee number. You could throw an exception called invalid name exception. You could throw an exception called invalid basic exception. And these would be different exceptions that you are throwing. So I want to be able to throw specific exceptions. At this point, obviously, this code doesn't work because I don't have an invalid P1 exception. Right? So this code obviously will not work. For this code to work, I will need to do what? What will I need to do out here? What will invalid P1 exception need to be?
User-defined exception.
It will have to be a user-defined class. And what is common in all exception classes? All of them inherit from where? All of them inherit from where? From exception. So I can think about doing what? I can create a class, public class, invalid P1 exception. And this invalid P1 exception should inherit from where?
Application exception.
I heard two answers. I'll take one, and the second answer is also correct, and that's a better answer, but I'll take the second answer a little later. So yes to both. So this is what I'm doing. I'm inheriting from application exception. Sorry, exception. So now if I inherit from exception and do this, right, then this code doesn't give me a problem. This code doesn't give me a problem. Now I can catch it this way. Obviously, then I don't want to throw an exception. What would I want to throw? What would I want to throw?
Invalid exception.
Invalid P1 exception. I want to throw this. Now it gives me an error here again. Why is this giving me an error?
Constructor.
Because I don't have a constructor that takes a string as a parameter. So let me create a constructor that takes a string as a parameter. Invalid P1 exception, which takes a string, whatever, let's say message as a parameter. And if I do this now, my code compiles correctly. My code compiles correctly. Let's try running this code and seeing whether we get what we want. So if I give 200, it's not giving me my error message, but instead it's giving me the default error message. So let's go back into our code. And the message that I'm passing here is being received here. But what have I not done so far?
We are not forwarding into exception class.
I need to initialize the message property of the exception class. One way of doing this was you could have done this dot message is equal to message, like you have been doing in your code all along. But this doesn't work. Why doesn't this work? Why doesn't this work? We saw that earlier.
Read-only property.
Because this is a read-only property. So this obviously doesn't work. What is the other way that you have seen when you receive a parameter in the derived class? How do you initialize the base class member?
Base class.
Correct. What do? You call the base class constructor and you pass it to the base class. So the base class constructor, the exception class, has a constructor that takes the message as a parameter. And this is what you've been doing in your code all along, right? The derived class should not initialize the derived class members in the derived class. Where should it do? What should it do? Simply pass them to your base class.
Base class.
Correct? This is what we've been doing all along now. And now this should work. So the message received here is received here first and then passed to your base class where it's initialized in the message. And we were all looking forward to doing this. My message coming out there. Are we clear on this?
Yes, sir.
Questions, if any? So this is how you'd be creating your own exception classes that can be caught in a catch block and work. Now I'll take you back to this and somebody give me the answer also. First time round. Currently we are inheriting from the exception class, but this is a custom class of mine. This is my own class that I'm creating. So instead of inheriting from the exception class, what is suggested is what? What should you inherit from? What should you inherit from?
Application exception.
Application exception.
So this is meant for all custom exception classes that you're creating. And that's the change I'm going to make. Application exception in turn inherits from where?
Exception.
From exception. So it will have all the same properties. And this is what we're doing out. Now the advantage of using this approach, is something like this. What would this code block catch? What will this code block catch?
All
Yes.
the system defined exceptions.
Which have not been handled before. All the .NET exceptions which have not been handled in your code before can be caught here. What about this block? What will this catch?
All the user defined exceptions that hadn't been
That have
handled
not
before.
been handled before. And what will this catch? What will this
All
catch?
the other.
All the exceptions.
Assuming somebody has not followed certain standards and they're directly inheriting from the exception class, then all such other exceptions which are not inheriting from system exception or application exception. So all such other exceptions can be caught out. And you can actually create more structured exception handling code. All right. So this is what you could do. Clear? So this is what we have been doing. In the developer class, we've been putting a console.writeline. You should not have any console.writelines in the developer class because that is going directly to the end user. Okay. In your assignment, currently you're following the older way we were coding. So today's assignment is that instead of in your properties, instead of a console.writeline, what am I going to ask you to do? Instead of putting a console.writeline there, what am I asking you all to do?
Throw new
exceptions.
So create your own exception classes, right? And throw those. Like for example, if the name was not valid, you should be throwing an exception called invalid name exception. If the basic was not valid, throw an exception which is invalid basic exception, and so on and so forth. Wherever you have written down validation code, in the else part, do not put a console.writeline. instead of the console.writeLine, replace them with exception classes that you create on your own, right? And then of course in the user section where you're creating, main this thing, you put in a try catch and you handle the exceptions. So both aspects you have to track. Are we clear on this? All right. It's close to 11:40 right now. I don't want to start the next topic, talk 20 minutes about it, and then take a break in between. So I'm going to give you a break at this point. You all can take a half-an-hour break at this point. It's 11:40 almost. Let's say by 12:10, we'll start the session again. And when we come back, we're going to look at the other approach. What if you don't want to inform the user in a critical way? We want to inform in a non-critical way. We'll discuss events at that time. All right. So see you all after the break. 12:10. We continue with the lecture. Bye for now. Was exception handling, and we saw how we could do that. Now let me take you back to the similar thing that we have been working with. So again, here you have a developer, a user, and an end user. Okay. Events, we said, are a non-critical way for the developer to let the user know that something has happened in his code. Okay. So they're like, there's a change of status. You just want to let him know that, okay, this is what has changed. This is what has changed. And then the user may or may not write code on it. Now, typically when you talk about a GUI environment, events are used a great deal in GUI environments. So let me take you through, we have not done this. And in fact, first time that I'm showing you something like this. Let me show you a simple GUI environment. Let me add a project. And instead of going in for a desktop application, instead of going in for a console application, I'll just take a Web Forms app, right? This is the dummy throwaway code. Okay. And if you look at this, instead of writing code, a lot of the things that you have out here are a visual element. So you see a visual form, for example, or you see controls out there and whatnot. And the way in which you'd be working with this is not so much by writing code, but by doing a drag and drop sort of a thing. So for example, what you're seeing here is a form. Okay. And let's assume I drag and drop this button out here. Okay. Now, what have I created out here? I actually created an object of the class button. When I dragged and dropped a button, this button is actually an inbuilt class. And what I'm creating here is an object of the class button. Right? Now, when you run this code, there are different what are known as events happening for this button. Right? Like, for example, one of the things that might be happening for the button is there is a click happening on that button. So when I go and click on the button, there's an event called click happening on the button. Or if I talk about the form is also an object of the form class. So when I move my mouse pointer on this, okay, there's a mouse move event happening out there, which is telling me where the mouse is currently. So it'll give me the X and Y coordinates, for example. Okay. I don't have a text box in this example. Supposing I had a text box and I type out some characters out there. So there's an event called key press that is occurring out here. So there are different events that are happening here in your code in as you go along. Now, when that event occurs, let's say there's a mouse move event occurring. I'm the user right now. Am I forced to take any action on this right now? Am I forced to take any action? Do I have to write down code? There's an event happening called mouse move. Am I forced to write some code for it right now?
No, sir.
No. So it's optional. Whether I write code for it or not is up to me. I am being informed that an event has occurred. Like for example, if there's a click event happening, I will get informed that a click event has happened. But whether or not to write code is entirely my prerogative. I may choose not to write any code. I might choose to write some code. Right? Now look at this example. I know I've not shown this example to you before, but it's okay. I mean, just trying to understand what is happening here. If I want to write some code, this is what I'm going to do. I'm going to double click on this. And this is where I'm actually writing some code. So what am I now writing code for right now here? What am I now writing code for? Button 1 underscore click. And click here is the name of the event that I'm going to write code for. So whenever the click event happens for the button, I'd like to do something. In this case, I want to do a message box dot show. Let's say, whatever, button click, for example. Right? And now when I run my form, when I click on the button, the code that I have written now executes and it shows me this button clicked out here. Right? Earlier, this was not happening. This is how it's actually working. Are we clear on what is happening here? I'm saying that the event would happen. I may or may not write code for it. When I drag and drop this button, when I drag and drop this button, what am I doing here in this case? What am I actually doing behind the scenes? What is it doing? Creating what?
Creating a class.
I'm not creating a class. I'm creating an object of the button class. Right? So who has created the button class? So if I'm creating an object of the button class, who has created the button class?
Developer, sir.
Developer.
Who's the developer in this case?
Microsoft called developer.
Correct. So somebody sitting at Microsoft is the developer. Yes or no? If this was a class button, somebody sitting at Microsoft would be the developer. All right. So if I have to take this scenario, let's say I have to explain this scenario. Let's say there is a class button. Somewhere there is a class button. Somebody has created a class button. And this has been done for you by the developer. Right? In the class button, you have obviously going to write down some code, and we'll come back to that code later. Now, in case you're creating an object of the class button, you are now the user. The user would do what now at his end? What will he do? In this example, he creates an object of this class button. And here, this of course was your button 1. And what else does the user need to do? What else did the user need to do? What else did he need to do? To write code for that click event. What did I need to do here? What did I do here? What have I written here?
Created, written an a function.
Function. All right. Now, without showing you this, I'm not showing you this, but when I drag and drop that button, behind the scenes, see what it's doing for me? Behind the scenes, what code is it generating? Look at this. What has it done in here? What has it created? Ignore this. What has it created here?
Object, but
Object of the table.
Right? It has declared a reference of type button. So what is button here? Button was the class, and button one is actually a reference of that type. Somewhere in its code, it is also doing this. What is it also doing?
object.
Initializing.
Creating an object of that class. Right?
Yes, sir.
So without showing you, it is actually doing what? It is doing this. Button one is equal to new button. Are we clear on this? This is the code that was generated for you. You didn't have to write the code. It actually, you dragged and dropped it and it actually created this code. So this is the code that you wrote out here. And then we wrote some other code. What else did we do out here? What else did we do out here? We had to go and write some other code. What have we also written here? A function
event.
for
Function for event.
button one, right? For that event. So I'm not giving the whole syntax. It's like a void button one underscore click. It won't fit here. I've written a function for this. Okay, ignore the other things. And in there, of course, you have some code written. Whatever the code that you want to run. Here, this was the scenario. Now, when you ran the code, this is what the end user saw. End user saw the window in action, and he saw it running. And who's the one who went and initiated that button click event? The end user actually did something. He went and clicked on the button. Right? So what did he do? Here is where my famous drawing skills come into play. What did he do? Yes. He went and clicked on the button with his mouse. This is excellent drawing skills. Well done. And when he clicked on the button, what happened is that the developer came to know that the button has been clicked. The developer we have not written any code there. The developer has written code which says that the button has been clicked. So what the developer actually did was something like this. It's a pseudocode format. If clicked, then raise the click event. Right? If the button has been clicked, then raise the click event. This is what he has done. And when this code, this is in pseudocode format, of course, when this code ran, when raise the click event ran, what happened now? Behind the scenes, what happened? Yes, what happened then? When this code ran, what happened now? What did it do?
Call to button one click function.
It called the code that I had written, right? Button one click. All right. So can I say that raising this click event is like calling button one underscore click? Can I say that? Is like calling button one underscore click. That function is getting called at that time. Agree?
Yes, sir.
Yes, sir.
All right. Okay, so let's summarize. Who's the developer? Who's the developer?
Someone at Microsoft.
Someone sitting in Microsoft. Whoever, we don't know his name. He's the one who's written this class. Whoever, John Smith. I'm giving some random name. Most likely it's going to be an Indian only. So maybe he's whatever, Ravi Rangarajan. Right? Whoever. Somebody sitting in Microsoft has written this code. We don't know whether it's John or Ravi or whoever. Right? Who's the user?
We.
Who's the user? Yes,
So us. We.
us, all of us. Of course, right now I did it for you, but you also would be writing similar code. So all of us are the users. We are creating an object of this class, right? We're creating an object of the class and writing a function and calling this code. Correct? End user is of course the person who's running the code and clicking on the button. Now think about this. When has Ravi written this code? The developer Ravi, when has he written this code? When has he written this code?
Don't know, sir. Somewhere in past. Sometime in past.
Whatever, 20 plus years back when the .NET code, was written, right? When you were, some of you all were small children or maybe not even born, somewhere at that time this code has been written. Okay. When has the user written his code? When has the user written his code?
Today.
Today, right here, right now. Right? Now think about this. This guy has written a button one underscore click. He's calling a button one underscore click for code that you're writing today. So how did Ravi know that on July 25th, 12:25 p.m., Vikram sitting in Mumbai would be creating an object of his class and writing a function? And he has to now call this function. How did he know that? Is there any way he could have known that? Yes?
No,
Is
sir.
there any way he could have known that? Obviously not. Right? So now, how is Ravi calling my code? How is Ravi calling my function? That is the
He
question.
might have set any event at that time.
Correct. Now try and understand this. He cannot call my function directly. Agree? He cannot call my function directly. Agree or no? Yes?
Yes.
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 So he has to call my function in an indirect way. And to call my function in an indirect way, he is going to use a delegate.
Delegate.
Right? So what would Ravi do? Ravi would first create a delegate class. Create a delegate class. Right? Okay, now we have seen that this is optional actually. He can do what? Instead of creating a delegate class, what can he do? He can use an existing delegate class also. But let's say for now that he didn't know how to create, he didn't know how to use action and func. So what would he do? He would create a delegate class. And then he would create an object of the delegate class. So he would create a delegate object. That's what he would do. Now this delegate object that he creates is going to be represented as an event. So what is an event actually? Internally, what is an event?
Delegate
An event is
object.
an object of that delegate class. So click, for example, actually internally speaking is what? Is nothing else but an object of some delegate class. All the events that you saw, all of these are objects of a delegate class. But syntactically, they will be slightly different. And I'll show you what the difference is. Don't worry about syntax at this point. Internally, what are they? They're an object of the delegate class. All right. So this is what, Ravi has done. Created a delegate class, created a delegate object. And instead of calling button one click directly, what would he do? What would he do? He would call the delegate object. So he would make a call to the delegate object. What is the delegate object here in this case? What is this delegate object? Is actually what? What is another word for this? What are we calling this?
Like,
Method
We
calling.
will call the event, basically.
yes, sir.
Another word for that I'm using is an event. So he'll use this. So this is what he would do. Now, whatever the delegate object is pointing to, whatever is pointing to, it would be calling it out here. Are we clear on this, everybody? Yes, understood. Okay.
Sir, repeat once again.
I'm saying, did you understand why Ravi can't call your method directly? Did you understand that part?
No,
Why
sir.
can't he call your method directly? Yes, no. Have you understood that part or not understood?
No, sir.
I gave you the example. When did Ravi write his code? When did Ravi write his code? Who is Ravi now? By the way, let me go one step back. Whom am I calling Ravi?
Developer.
Developer.
Who is this developer? Who is this developer? If you have not got that, then you don't know what I'm talking about. Who's the developer? Who's Ravi? Who's this developer Ravi whom I'm talking about?
Microsoft.
The guy sitting in Microsoft who has written this code of the button class 25 years back when this .NET framework was being made. Who's asked this question? No, who's asking? I can't make out. Who's asking this question? Yes? Was it Swapnil? Who asked me the question? I'm not going to eat you. I just want to know. I'm going to say, okay, give your name out there.
So which question? Repeat.
This question, can you repeat the explanation? I didn't understand.
Okay.
Who asked this question? I matlab kaun?
I didn't ask the question, but I wanted to know which question.
Does this happen only on Monday mornings or other days of the week also you all do this? I will tear out my hair in frustration. Only thing I don't have it. Okay, let's just say Kaustubh asked this question. Okay.
Okay, sir. Sir, let it be. I asked this question. Aditya Sharma.
Darling, who's I? I can't see your
Aditya
name.
Sharma, sir.
Aditya. Okay. Thank you, Aditya,
Yes.
for being the sacrificial lamb. So assuming Aditya has written this, code for the user. Aditya is the user right now. How is Ravi sitting at Microsoft knowing 25 years back that Aditya is going to write some code later that Ravi needs to call? There is no way he can know that. So the problem is calling this code button one click cannot be done directly, because when Ravi wrote his code, Aditya was not even born. So there is no way that Ravi would have known that 25 years later Aditya would be trying to create an object of his class. So in such a case, you cannot call it directly. You're forced to call it in an indirect way. And we have seen this before, that if you want to call a function indirectly, you would be using a delegate. So now I'm getting into the section where what does Ravi need to do? So what is the first step that Ravi needed to do? What did Ravi need to do first? He needs to create a delegate class.
Yes, sir.
Second step is, what does he need to do? He needs to create a delegate object. I'm saying another word for the delegate object is your event. So the event is actually a delegate object. So if you took click as an event, the name of the class was button and the delegate object was called click. So an event is internally an delegate object. And to call that event, you would just call it like you would call a delegate object. So basically the event name, or what is the event actually? Event is nothing else but the delegate object. So the delegate object name or the event name. That is what Ravi needs to do to raise the event. Understood?
Yes, sir.
Yes, sir.
Now we are moving to the second section. What does Aditya need to do? What did Aditya need to do? So Aditya firstly needed to create an object of the button class, of that class that he's creating. He needs to create that. Secondly, Aditya needs to write a function that should be called when the click event is fired off. So Aditya will do what? He will write his function as well. And the third thing that Aditya needs to do is he needs to do something like this. Button 1. What is button 1? What is button 1?
Object.
Object of that button class. Dot delegate object. Can I use the word event instead of delegate object? Can I use the word event? Because I'm saying the event and the delegate object is the same. So button 1 dot event name is equal to button 1 is equal to button 1 underscore click. What is button 1 underscore click? What is button 1 underscore click?
It's a function.
Method we
The
written.
function that I have written down. The method that you have written down. Are we clear on this? So what are you passing to it? You are passing to this delegate object. You're passing the function that you have written. And that's how this delegate object knows how to call your function. That is all that you need to do. That is all that the user needs to do. User needs to write his own function and pass this function to the event. So when he calls the event, what will it automatically call? Whatever that event is pointing to. In this case, your function that you have written out. Are we clear on this, everybody? This is how events are written and handled in .NET.
Sir, basically we are overriding button 1 click, right?
We are not overriding that. We are giving it the event or the function that we want to call. We are not overriding it. We are adding to that list. Remember, all delegates are multicast delegates. Meaning what? You're just adding to that functions. Okay, I want to call this function when that particular event is raised.
Sir, then what happens if a end user clicks a button? Then what
So
will
when he
happen
clicks
in
the button, the first person who knows about it is the button class. So button class says, okay, if there is a mouse down and the mouse are occurring on me, then I'm going to go and raise the event. So this is the code. If clicked, then raise the click event. That is what's happening in the button class. The button class is recognizing all of the things. So whatever actions that the user might be performing, end user might be performing, the class nodes in his code. And that's how he is raising the event. So when he's raising the event, he does not know what your event handler is. So the event handler, you have to specify. All right.
yes, sir.
I showed you event handling with a visual example because it's easier to understand it that. But we are going to do this without a visual example. We're not going to have an actual button object anywhere or whatever. We're going to create what? We're going to write our own code to do the same thing. So let's go back into our code. Okay, so see what I have done out here. You have to again try and keep it simple. I have got the same code that we did for exception handling. I'm going to now try the same example, but instead of throwing an exception, I'll be raising an event. So in my case, when would I raise the event? When would I raise the event?
Validation at the
Correct.
timer.
So if the data that I'm accepting is valid, accept it. If the data is not valid, then raise an event. That's what I'm doing in my code. Now, my question to you is, before I begin, is if data is not valid, should you throw an exception or should you raise an event? If data was not valid, what should you ideally do? Throw an exception or raise an event?
Throw an exception.
Throw an exception.
Throw an exception. Data not being valid is the most critical thing that can happen in your application. Your entire code that you're writing is to ensure that values that are coming in are proper values that are coming. All the things that you do in your code. This is your main objective. Your objective in life when you're coding is to make sure that data that comes into a system is properly validated data. So if data is not valid, that is the most critical thing that can happen in your application. So ideally what you should be doing is what? Throwing an exception. That is what you should always be doing. But in this example, just to explain to you how events work, I'm going to take the same example, and instead of throwing an exception, I'm going to raise an event. All right. So right now, put on the cap which says developer. Put that on your head right now. Right now, what are we doing? Whose job are we doing? We're doing the job of the developer. Who are we right now? The class developer. Right now, don't worry about the user. Right? Okay. What is the first thing that the developer needs to do? What is the first thing that the developer needs to do?
Create a delegate class.
Create a delegate class. So let me do what I'm asking you to do. Step 1. Create a delegate class having the same signature as the event handler. Create a delegate class having the same signature as the event handler. Now let me explain the statement in a couple of ways. First thing, give me the syntax for that. Public, help me. Delegate class will be what? Public, delegate, and then the delegate name. Then the delegate name. Okay, now I can call it del1. Can I call it del1? Yeah. All right. I have a confession to make again here. There is actually a convention that is followed here. You don't just give it any name. There's a convention that generally is followed. Convention is not compulsory, it's optional. So do you want me to follow the convention, or do you are okay with no convention?
We want you to follow the convention, sir.
Yes.
Not okay.
I was trying to keep it simple for you, but you all are now telling me no, you must follow the convention. Your choice. I didn't say that. I was okay with calling it del1. But
Sir, but we would be
voices from your
unaware of the
batch.
convention then.
No, your choice entirely. I'll follow. I'm not saying no. I'm just saying that who asked me to follow a convention? You all did. I didn't choose that. So the convention is, if your event is called X, your delegate is called X event handler. That is the convention. If your event was called X, what will your delegate be called? X event handler. So if your event was called click, your delegate would have been called click event handler. Now I want to call my event, if P1 is not valid, I want to call my event invalid P1. I want to call it by that name. So what will be the delegate name? What will be the delegate name?
Invalid P1 event handler.
Invalid P1 event handler. Right? That's the convention that you're using. Now, listen to what I'm saying very carefully. All events will always return a void value. All events always have a void return. So my delegate also will need to have a void return. The standard, all events all over always have a void return type. Right? So my delegate also has a void return type. And the parameters to the event would depend upon what you want to pass to the event handler. Like for example, let me give you a few examples. Let's say there's a click event happening. Now, along with the click event, there is no extra information coming to you. It only tells you what? That the click event happened. But if there is a mouse move happening, or if there is, let's say, a key press for a text box happening, then there is extra information that is given to you. Like for example, if there is a key press event happening for a text box, what additional information would you possibly need to know?
Which key is getting pressed?
Correct. Which key is getting pressed? So now key press has a parameter. And the parameter will be what? What will be the parameter? What is the key being pressed? Or if I take mouse move, if I move my mouse, what do you think will be the parameter?
Coordinates.
The X and the Y coordinates. Where exactly is the mouse right now? It has moved to where? X and Y. So those coordinates will be the parameters out. So an event may have extra information about it, which will be passed in the parameters. In the first example, I am not passing any parameters. What am I saying now? Right now, I'm just going to say that there's an event occurring called invalid P1 when P1 is invalid, and I'm not passing any parameters. So this is what I have to declare the delegate as. Have you understood this statement? Create the delegate class having the same signature as the event handler. While creating this, return type always will be void, and the parameters will depend upon what information you want to pass in the event. Step 1 done. Step 2. What do you do in step 2? Look at this.
So create an object.
Create a delegate object, right? Which we are calling as what? Which we are calling as a
Event.
So we're going to come back into our class and create a delegate object. Help me create an object of this delegate type. Help me in this. Come on. Help me create a delegate object. This is your delegate class. Help me create a delegate object.
Invalid P1 event handler.
Public invalid P1 event handler. And the name of this, I'm calling it as invalid P1. What is invalid P1 here? What is this actually? It's a
Reference.
yes, it's a reference of that type, and we are saying that this is actually an event. This is actually your event. Are you getting this, everybody? All right. Now, I'm going to add one more keyword out here. To explicitly tell you that this is actually an event. And the word I'm adding here is public event so and so. All right. Now this makes no difference to the code. Your code will work the same way even if you don't give the keyword event. Even if you don't give the keyword event, your code will work exactly the same way. But I'm explicitly saying, Achha, this is actually an event. Now the difference that this makes is not to your code, but to Visual Studio. And I'll show you later how it makes a difference to Visual Studio. But your code will remain exactly the same, with event or without event. Okay, so we have created the event. Third step, easy. What do you do? Third step is what? Third step is what? No. What are we doing in the third step?
Setting an event.
Just basically raising the event. The term here used is you throw an exception, but you raise an event. When do you want to raise the event? That's up to you, whenever you want to. Whenever you want to inform him something has happened, you raise the event. In this case, when am I doing it? I'm doing it when the value is not correct. In this case, how do I raise the event? What will you do? Simply what? Simply what? Simply what? Simply do what?
Call the object.
Call the delegate object. Call the event delegate object. By giving the function, by event name. Event name was invalid P1. So, invalid P1. Do you see invalid P1 now? Do you see this? What should you be automatically looking at? When you see the code, what should you be by now? What should you automatically be looking at? At the symbol. What is the symbol of an event?
Flash side something.
It's like a lightning bolt, right? Have you all seen Thor?
Yes, sir.
We have one guy from, who's wearing a Superman t-shirt. So he's probably from the other side. But anyway. But you saw Zeus, right? Having that lightning strike. So that's the same one. Okay. Marvel borrowed it from Visual Studio. So lightning, something happening, like an event. It's like a really happening thing. Let's go for this event. It's a happening thing. So that's your invalid P1. Why I'm asking you to look at the sign is so that you can identify an event whenever you look at it. All right. So that's invalid P1. That's it. Ravi's job is done. Ravi can go home now. Right? Ravi can pack his bags and go home. What has he done? He's first is declared the delegate class. What is step 2?
Created event object.
Yeah. So declare an event, which is actually a delegate object of the delegate type. Right? And third step is what? What are we doing here?
Raising event.
Raise the event. Step 3 was raise the event wherever you want to. Whenever you want to raise the event. Ravi's gone home at this point. Okay. Why has Ravi gone home? He's done with what he needed to do. Now we need to step in. So take out your developer hat and keep it aside and wear your user hat right now. Right? Wear your user hat right now. So we're going to be writing this code in class program. Help me. What should this guy do? What should the user do? First step, what would he do?
Create
First
an
step,
object.
create an object of that class, of the delegate class or of the like in this case the button
Class 1.
Class 1, the main class that you're using. So help me do that. Give me the code. Come on.
Class 1 O is equal to new class 1.
Okay. Class 1 O is equal to new class. That's the first thing he's done. Second thing he has to do is, I'll help you with this. He has to write the function. He has to write that function, right? So I'm going to write this function. Static void O underscore invalid P1. The function name can be anything. You know this. Doesn't have to be a particular name. It can be any name. Right? But I'm using the same convention that they had. What convention did they use? Object underscore event. Right? Button 1 was your object. Click was your event. Object underscore event. I'm using the same convention, but can I give it any other name if I want to? Yes?
Yes.
Yes.
Absolutely okay. But I'm just using the same name. Okay, this is your event handler. So write down the code for what should happen when the event is fired off. That's the event handler. Like this, like the button click. So the second step done. Third step, the one in red, what are you doing here? Third step, what are you doing? What are we doing?
We are equating the object to the function.
Right. So this is the object of that class 1. So object dot event is equal to the function. Object dot event is equal to the function name. But while doing this, you're going to use slightly different syntax and see whether this makes sense to you or not. So object dot event. What is the event name here in this case?
Invalid
P1.
All right. If you're not sure about it, look out for the lightning. Right. So that's your event. Object dot event. We're not going to do a equal to this thing, but we're going to do a plus equal to O dot invalid P1. Do you remember plus equal to?
Yes, sir.
Yes, sir.
Right? You use that in multicast delegates. So we are saying plus equal to, and we'll come to the significance of that in a minute. So what are we saying here now? What are we saying? Effectively, in simple words, what are we saying? If the invalid P1 event occurs, call O underscore invalid P1. This is what this line means. Right? We are adding a handler. We are saying that the technical term here is add an event handler for the event. In other words, simpler words, if the event occurs, then go and call this code. Are you getting this, everybody?
Yes.
Now, when would the event occur? At what point would the event occur? If you look at this code, at what point would the event occur?
When we assign value to P1.
Which is what?
Invalid.
Which is greater than 100. 100 or greater than 100.
Yes, sir.
Okay. So let's first assign a valid value. What if I said P1 is equal to 10? What will happen now in this case? If P1 is 10, then what will happen?
If block will be run.
So which means your event would not be raised. And
Yes, sir.
this code will not be called. As simple as that. Let's confirm that. Let me see if this is a startup. Yeah, it is a startup. Right? So at this point, what happened? Nothing. Nothing happened. And I'm okay with that. I'm telling you that the event did not get raised. But when would it get raised? If you put in a value of 100 or more than 100, that's when it will get raised. So I put in a 200 value here. It will go into the else part and it will raise the event. Now, when it raises the event, whatever you have passed out here, that will go and get called. So now what happens? What's the output difference in the output now? Is that your event handler is getting called. So this is how you are linking your code with what Ravi had written. Are we clear on this? Questions, if any? Yes. Somebody's trying to speak. I don't know whether there's a question or whether by mistake. Yeah.
Sir, please scroll a bit.
Scroll down.
Yes, sir.
So this is what was the earlier code. It's what the developer did. What's your question?
No, sir, understood.
Okay. And this is what we're doing in the user section. All right, clear?
Yes, sir.
Okay, now if you've understood this section, if you understood this, I'm going to make life a little easier for you. If you have understood this, let's do this a slightly easier way. So let me comment out my code out here. Let me comment out my code. And let me start by saying, what if I was writing my code from beginning? Static void name. Okay. What is the first step that you have to do? Create an object of that class, so that's not changed in any way. All right. Now look carefully. Look carefully at what I'm doing, because it's a Visual Studio thing. What I'm doing here is all that I'm saying is object dot event. What am I saying? Object dot event. Will you remember that part? Object dot event. See what I'm doing? I'm saying object dot event. Here in this case, event was invalid p1 plus equal to, and see what Visual Studio prompts me with. What does it say? What does it say?
Over method.
O underscore invalid p1, and more importantly, look at the right hand side.
Press tab to insert.
Press tab to insert. So when you press tab, it generates this event handler for you. Are we getting this, everybody? It generates this event handler. So you don't even need to write that function. Let me do it again. Let me do it one more time. What am I asking you to remember? I'm asking you to remember object dot event plus equal to, close your eyes and press tab. Close your eyes and press tab. If you don't close your eyes, code doesn't work. All right. And then whatever code is generated, all that you do is what? Come and specify whatever code you'd like to have. So it becomes really easy to write this code because Visual Studio is helping you generate the handle. All you need to remember is object.event plus equal to. And then what? Then what? Object.event plus equal. No.
Plus equal to.
Plus equal to, then what?
Press
Close your eyes.
Close your eyes and
That's
tab.
the most important part. Why I'm saying close your eyes and do that is because don't do anything else. Just press tab. That's why I'm telling you. Okay? Close your eyes and press tab. Let it generate the code for you. Don't worry about anything else. Are we clear on this? And this is how you could actually go and write down the code. Of course, then the next part of the code was doing what? What was this doing? This was actually firing of the event, but adding the event handler became very easy. Then complete whatever you need to complete. Okay. So from a user perspective, it becomes fairly easy. Very, very simple. When you say plus equal to, what is this plus equal to doing? Plus equal to is what? Is
Multicast.
Adding an event.
adding one more handler. So do you think this should work? Remember we said function name can be anything. Do you think this should work? Yes or no?
Yes.
Do you think this should work? Handler 2. And you can actually generate the method here. If you're feeling a little lazy, generate that method. Or simply copy paste and write down the code. Right? Now, obviously, if plus equal to works, then what should also work?
Minus equal.
Minus equal to. So what would happen now if I did this at this point, and then again I did this. I did this again. So what would happen now? What is the first time? Which handler will it call? At this point, which handler will it call?
Both of them.
These are all
Invalid.
very simple answers now.
Invalid P1 and handler 2.
Both of them would be called at this point. At this point, what will be called? Sorry, not plus. Minus. I'm so sorry. At this point, what will be called? Second.
Only invalid P1.
Only invalid. So you can at runtime dynamically add or remove handlers. This feature is called as dynamic event handling. So .NET supports dynamic event handling, which means handlers can be added or removed at runtime. Okay. Actually, just one more thing. Now what? Now what? Now what?
Nothing, sir. It won't call anything.
So it does not have any handlers. So it should not call anything. Let's confirm this for the last one. When you try doing the last one, it throws you a null reference exception. So why is it giving you a null reference exception?
Because it is not pointing to any.
Because invalid P1 now is null. Now whose code is the problem? Is it my code the problem or is it Ravi's code the problem?
My code.
No, Ravi.
So, but
I
it
don't
is
want to
not.
have a handler. No? Events we said are optional. You need not. Ravi is just supposed to inform me about it. And then whether I choose to take any action or not is up to me. I should not be forced to take any action. So Ravi's code should handle this. But where is Ravi right now?
At home.
He's gone home. So you need to call him back. And you tell Ravi, please handle this. So Ravi has now come back here. Can you help Ravi handle this? What will you do out here to help Ravi handle this?
Sir.
When is it giving a problem?
So try catch block and to catch null reference.
Eliminate the error if possible. Try catch says what? If the error occurs, then ignore it. I'm saying eliminate it. So what would be the better option? If invalid P1 not equal to null, then only raise invalid P1. So if it is null, then do what? If it is null, then do what? Then don't do anything. So this is what Ravi needed to do in his code, which he had conveniently forgotten. How dare he? So come back, write the code. So now Ravi can go back. Are we clear? So now what are we checking out for? If there are no handlers and you call this, then nothing will happen. Nothing will happen, and that's okay. That's how the code should run. Are we clear on this, everybody? Questions, if any, with any of this?
Sir, does that mean user does not know what Ravi has written in his code?
Obviously.
Okay.
Ravi is a different entity. The user is a different entity. Two different people. One is creating the class, the other is creating an object of the class. So you don't know what one is writing and the other is doing. You don't know that. So which is what I started off my discussion right in the morning with. I'm saying that whenever you're doing these two different tasks, each one does a specific task and one need not know about the other. In your case, what you all do is you all are the user also, you're the developer also, user also, and you're the end user also. So I'm not joking. I asked this question and one of the people who came to me with a problem. And I said, you're not written validations. He says, yes, sir, I've written validations. I said, I can't see a single validation in your code. I said, how do I validate that the value being entered is correct or not? He's saying when I'm entering correct value. That was the answer that I got. I won't tell you who gave that answer. He's saying, see, I'm entering correct value. If I give incorrect value, then I don't know, but correct value I'm entering, sir. Which is what my angst with you is, that be clear about what you're doing out there. Okay. All right. We're going to play around with this code a little bit. So what we did here was we had an event which had no parameters. We had an event which had no parameters. Now, what if you had an event which had parameters? Like for example, when I raise the event, I want to pass back what was the wrong value that I got. So I'm going to say invalid P1, but I'm going to also pass back what is the wrong value that was sent to me. I'm passing it back to the user. Okay. So this wrong value, I'm going to be passing it as a parameter to the event. Parameter to the event will contain extra information about that event. All right. So help me. Do I need to change anything in step 1?
97 line number.
What would I need to change? What would change?
Add parameters.
Parameters.
The delegate would have the same signature as the event handler. So I want to pass back what was the wrong value that was being passed. I'm passing this as int invalid value. This is the wrong value that was being passed to me. Right? The second one, what changes would I need in step 2? What changes would I need in step 2? Yes?
No, nothing.
No changes, because all that you're doing is what you're saying invalid P1 is of type invalid P1 event handler. So that's taken care of. Step 3, what changes should I require? Look at invalid P1 now. What does it take now? It takes the invalid value as a parameter. So help me with this. What would be the invalid value? How do I know what is the wrong value? How do I
Value.
value? So value is giving me the invalid value. That's what I'm passing back. If you had an event that had parameters, this is how you would go and make the changes in the developer code. And in the user code, help me with the user code. All that I need to do is what? Create an object of that class and what? and what? Now what?
Object
Code
dot
dot
Object dot event name.
Object dot event. Then what?
plus equal to
Plus equal to
close your eyes.
and
This
tab.
tab.
Press
This
tab.
eyes and what? Go to sleep. No. Close your eyes and press tab. Remember, it does not work without closing your eyes. Okay, and then do this. Now, if you notice, the event handler got generated with what? With the correct signature. And here I could do this console.writeLine, invalid value, and then print the invalid value plus invalid value. Right? Fire of that again, you do what? O dot T1 is equal to some value, and when that fires off, this is the code that would run. Let's try running this, and you got that invalid value 200. Okay, so this is how you can have parameters to events. Now, events are used a lot in .NET when you have some UI. That's why I took my initial example with you. I showed you a Web Forms application. I showed you a desktop application. Even though you've not worked with it, but you would have understood it better with this sort of an explanation. So events are used a lot in here. Let me take you to that application again. Like if you look at this, if you take a button, for example, and do you see this here? You see this? What are these?
events.
All the events for the button. So these are all the events that could happen for a button, for example. And we have written code for which event? We have written code for the click event. So wherever you're going to be working with UIs in .NET, events are going to be a major part of it. In .NET, we generally write event-driven code. Okay. All right. Now, one of the things that I did here, was I gave the keyword event. I gave the keyword event, public event, so and so. And when you give the keyword event, only then will it be shown here in the list of events. So if you don't give the keyword event, I told you what would happen. Your code will work fine, but Visual Studio will not be able to identify that that is an event. And therefore, in the list of events, it is not shown out. So which is why that event keyword is required for Visual Studio to understand that this is an event. Right? Okay, I just want to take you through this code that was generated. What did we do? We double-clicked on the button and we wrote code for it. Now, behind the scenes, what all code did it generate? What all code did it generate? See what it generated? It first did what? Created a reference of that button type. So button 1 is of type button. Right? Second thing, what did it do? It says button 1 is equal to new button. So it generated this code as well. So similar to what we were doing. What were we doing? We are saying class 1 O is equal to new class. So this is the same thing that we did. And the third thing, look at this. Look at this. I'll make it a little easier for you to read it. Can you understand this line?
Event.
Multicast.
What is this line saying? Button 1, this is what they wrote. Button 1 dot click plus equal to, what is event handler? Is the name of the delegate that handles click. And they're saying new system dot event handler. When you're using a delegate, can I omit the word new and directly give the function name? So we wrote code like this. They wrote code like this. Right? But the code that they wrote is the same as the code that I have written on the next line. Are we clear on this, everybody? So all this code was generated for you. I didn't have to write this code. When I dragged and dropped this, all of this is being generated for you behind the scenes. But always it will not be generated. You'll have to write your own code at some point of time. Achha, by the way, what will happen now? If I click on the button, what will happen now? Right now, what will happen? If I run this code and I click on the button, what will it do for me right now? Come on. I have gone and made some changes in their generated code. What will it do for me right now if I click on the button?
So that message box will pop up twice.
Correct. So this function will be called twice. So let's try running this. So when I click on this now, that's the first time, and I click OK, and then the second time it's been called. So that's actually calling the function twice. Are we clear on this, everybody? So anyway, you don't need to worry about the WinForms example. The WinForms example I had only taken up just to help me explain better what is happening. But you can focus on this example. All right. So let's move away from events. Let's move away from events. And yeah, what we have 40 minutes left. Okay, let's go for it. I'm debating in my mind whether I'll be able to finish in 40 minutes the next topic I'm taking. And my mind said, doesn't matter if it goes beyond 40 minutes, we will extend the session. Okay. So what we're going to do next is we're going to see one more place where delegates are used. Right? So we've seen one place where delegates are used. Where did we see one place where delegates are required is where? In event handling. Right? So one more place we're going to see where delegates are used, and we're going to try writing async code with delegates. First thing, let me put into words what I mean by async or sync code. Let's say you're writing three functions: function 1, function 2, and function 3. Now, by default, these are synchronous in nature, which means that unless function 1 is over, function 2 will not start. And unless function 2 is over, function 3 will not start. So all of these three functions run on a single thread, right? And sequentially, one after the other, they will be called. Okay. Now, there might be situations in your code wherein, firstly, what is one of the prerequisites for asynchronous code is that the functions are not dependent on each other, which means it does not matter in which order they finish executing. That's the first prerequisite for asynchronous code. So what if these functions were not dependent on finishing in a certain order? I want function 1 to finish, function 2 to finish, and function 3 to finish. And the order did not matter to me. In such a case, instead of running these on a single thread, and here right now what would happen? Right now with the asynchronous code, what is happening? Function 1 runs, then function 2 runs, and then function 3 runs for some time. So unless one is over, the other one can't start. This is what is happening currently with a single thread. As opposed to that, I can think of, if this is your main thread, let's say, okay, if this is your main thread, I can think of starting function 1 on a separate thread. I can think of starting function 2 on a separate thread, right? Or function 3 for that matter, on a separate thread. Now, if I start them on separate threads, first thing is, no guarantee which one will finish first. Second thing here is, what will you achieve by doing this? What is the advantage of running in parallel on separate threads?
Multitask.
Your code would run faster. Right?
Reduced
Your code would
execution
run
time.
faster. Again, there's an if in there also. Your code will run faster if you have multiple processors. If you had a single processor, then your code will run actually slower. But if you had multiple processors, then your code will run faster. Most machines nowadays have multiple processors, so you can benefit from threading. Why am I saying if it's a single processor, it will run slower? Why will it run slower? Because only one processor is there. So when it's a single processor, it will use the concept of time slicing. Whereas for some time, let's say function 1 ran. Then for some time, function 2 ran. Then for some time, I'm just writing 3. I don't even write F1, F2, F3. Sometime 3 ran. Then again, it switches back to maybe function 1 and not finished. Switches back to 1, then switches back to 2, then switches back to 3, and so on and so forth. So you get these, if the function doesn't finish executing in that given time, you're getting these time slices. So for some time, function 1 is running, then 2, then 3, then back to 1. Now, why am I saying on a single process this will run slower? Why will it run slower than a single thread?
So it would be slower for F1. I mean, total time would be same, I think.
It won't be same. There'll be a slight overhead. So why will there be a slight overhead?
So that switching also takes time.
Switching, exactly. The overhead will be in the switching. So slight overhead, not a major, but a slight overhead. So don't just randomly use multi-threading. If it's going to benefit you, then it makes sense, right? So prerequisite, firstly, to begin with, functions should not be related to each other. Secondly, what? You have multiple processors. If you want, then only you can think of running multiple codes at the same time. Thirdly, what if, for example, you had a very long running function? Let's say function 1 took 1 hour to complete. And function 2 and 3 took, let's say, 3 seconds each. So if you're running it synchronously, then unless one finishes, 2 and 3 can't start. So if you have a long running function going on, it blocks all other code. So how can you improve on that? You can run them in, if they're unrelated to each other, you can run them as separate threads. So even if one takes a very long time, what will happen in the meanwhile? What will happen? Supposing one is taking 1 hour to run. In the meanwhile, what will happen? Because of the time slicing feature, or this thing, 2 and 3 can finish. So if you've got one function which is doing a very long running code, your system becomes unresponsive. Cannot do anything else while that's happening. So threading can make your system more responsive, and it does not block shorter functions. So there also you could use threading, right? Another place where you can use threading is if, let's say, in one of the functions, there's a lot of UI that's happening. The user is entering in some values. So while he is typing out, the processor is not busy all the time. But while he's typing it out, some background threads could run, performing some other tasks. So there will be a lot of situations where threading would help you speed up your code, right? And any code that you're writing with threads is referred to as asynchronous code. Now, what we're going to do here in this session today is we're going to see how we can write asynchronous code with delegates. Right? In .NET, there are multiple ways of writing asynchronous code. Delegates is the first thing that we're going to look at. There will be other options that we'll be seeing, not today, definitely not today. maybe in a couple of sessions down the line, we'll be looking at other options out there. Are we clear on this? All right. So let's have a look at this. Let's look at these functions that we have out here and how we can write it with delegates. I'm going to add one more project out here and console app, calling it sync code with delegates. Okay, so you're going to help me with this. You're going to help me with this. And I'm going to call my favorite function, which is display. Console.writeLine, whatever, display called. Right? Readline, making it wait. Let's make this as the startup object and console.writeLine, let's say before, and a console.writeLine after. So here's where I'm calling display and I'm doing a before and after. Let me call display with a delegate. Let me call display with a delegate. Quick, come on.
So we have to create the delegate class first.
Action.
Action.
Yeah, correct.
Action.
Yes.
What? O is equal to new, or forget new directly, what is equal to display. Right? And then how do you call it? Simply O. Now this here is a sync call. It's a synchronous call. We're not using async code out here. We're not using async code. To give you an example of what's happening, I'm just going to simulate this. I'm going to say that this is a very long running function. System.thread.sleep. This is putting in delay out here. So let's say I'm putting in a 3-second delay. The sleep instruction is only for the thread, not for your. And what I'm saying is what? For 3 seconds, don't do anything. Right? For 3 seconds, don't do anything. Now, I'm just simulating you. What if display took a long time to run? Now, because it's synchronous code, how will the output come? First this before, then display, and unless display is over, after will not be shown. So let's run this and confirm this. Look at the output before 3 seconds, display, and only after display is over, then after. Now we don't want that. We don't want that. This is a synchronous call. We want to make it an async call. Now, if you want to make an async call, then instead of calling it directly as O, you call this method with begin invoke. You call it with begin invoke. And when you call it with begin invoke, this now here is an asynchronous call to it. When I say it's an asynchronous call, it means that the display function will be now run on a separate thread. It will not be on the same thread. It's going to run display on a separate thread. What are the parameters to begin invoke? Look at the parameters. Read out for me what are the parameters. First parameter is what?
Sync callback.
Async callback. Async callback. I don't know what it is. Let me pass that. I don't want to pass that. Async callback, God knows what it is. No, chalo. Second one, what is it?
Object.
Object. Who knows? Who cares? Let me just pass that. I don't need it. I mean, let's first try calling begin. But there were two things that it asked you for. One was async callback and second one object, which we said right now, just don't bother about it. So what is this going to do? This is your async call. Would start off display on where? On a, we'll start display where? On a separate thread. Are we clear on this, everybody? So now how would the code be different? If this is going to run on a separate thread, if this line is going to run on a separate thread, how would your code be different now? How will it output be different?
Before.
Yes. Starts with before. Does this on a different thread. So does not wait for that thread, and it automatically carries on with the next line, which is doing what?
After.
After. Let's try running this and see the difference. So you got before and after immediately. But 3 seconds later, you got the display completed. Have you understood the difference between what happened earlier and now, everybody?
Yes, sir.
All right. Questions, if any? Simple?
Sir,
Yes.
what is difference between multi-threading and asynchronous call?
Same thing.
So why both are given as a different?
They're not. Who said that? Did I say that?
No, sir, I think that.
I didn't say that. I said, I wrote also here. I said async code with delegates. Then I started talking about threads. And I'm saying you're going to run this on a separate thread. So async code is what? Running code separately on a different thread. I never said it's different. Right?
Yes, sir. Yes.
Okay. We're going to do this in stages. So what did we do here? Call a function asynchronously using delegates. That's what we did. Right? How did we do that? What did we do for doing that? With the delegate object, you called it with begin invoke. This was the line that you wrote that caused it to run on a separate thread. Okay? Clear? Okay. Main one. Okay, I'm going to make a small change in here. The change I'm going to make in here is that display has a parameter. Display has a parameter. Right? Tell me what changes would I need. Okay, let me, the parameter that I'm receiving, I'm going to print the parameter.
Func.
Yeah, what are the changes that I have? Func. Huh? Func. When do you use func?
When there is a return type.
When your function has a return type. Does it have a return type?
No, sir.
What does it have?
Parameter.
Parameter. So what would be the change?
Beside action, yeah, angular brackets and string.
Okay. Action of string O is equal to display. Correct? Okay. Now, moment you do this, moment your action has a parameter, see what happens with begin invoke. See what happens with begin invoke. What does begin invoke now contain? How many parameters does begin invoke now have?
3.
What is the first parameter?
String.
String. And what are the last two parameters? What are the last two parameters?
Another.
At async callback and object. So when your function that you are calling had zero parameters, had no parameters, your begin invoke had two parameters, which were async callback and object. But the moment your function got a parameter, begin invoke signature also changed. And now begin invoke initially will contain the parameters that have to be passed to your function. And the last two will always be async callback and object. Are we clear on this, everybody? So here now, what I would get here is, if I'm passing it a string, this parameter would be passed to the function that you are calling. This is where you're calling the function, right? Begin invoke is calling the function. This parameter would be passed to the function. And then who knows and who cares what the last two parameters? I'm not worried about them right now. Let's see how we could do this. So what will be the difference in the earlier case and now? You're receiving a parameter. Function has a parameter. Let's try running this. Before, after, and then 3 seconds later, you got your display with the parameter that you are passing, which is hello. So what did we do different in here? Function has parameters, right? When you call o dot begin invoke, first you would have the function parameters, and then after that the last two would be the parameters that begin invoke had. This is what you would get out. Are we clear on this? Yes.
Sir, I have a question.
Yes.
Where is begin invoke is a written? I mean, in threading or in delegates? Which class is inherit?
Delegates and okay. What if I told you that delegates use threads and threads use delegates? I'm saying that delegates use threads and threads also use delegates, right? So don't worry about that. We will see threading and then we'll see how it's different. The only difference is when you use delegates, you're using threads that have already been created. And when you're creating your own thread class, then you're creating a new thread yourself. So we'll talk about all of that. Don't worry about it.
Okay.
All right. So to answer your question was where will you use begin invoke? You will use begin invoke when you're using delegates. Okay. All right. So 2 done. Again, Control C, Control V, and I'm going to make a small change, very small change. So this now does what? Returns a string. And all that it does here is it says return s dot to upper. So whatever string that I have received, I'm returning that string back, but in uppercase. So if I receive hello, this function will return what? Will return hello, but as uppercase. Changes in my code. What changes should I make? Now you got your func. So only func with string, that's it. Func string or anything else. Func what? String. Why string? Parameters and then the return. Are we getting this? All right. Now, can I say, now suppose I want to get the return value, string return value, right? And here, what if I did this? Return value is equal to o dot begin. This is where you're calling the function, right? This is where you're calling the function, correct?
Yes.
And then the function returns a value. So what if I get the return value this way? Would this be okay? What if I get the return value in this way? Should this code be okay? Or
Yes, I guess.
or is there something fundamentally wrong with this approach? Is this approach okay, or this approach itself is flawed? Don't worry about the syntax. I'm asking about the approach. Is this approach okay? Is this way of writing code okay, or something wrong in this approach? What do you all feel?
Unnecessary lengthy code.
Unnecessarily?
Code will be lengthy.
Lengthy code, don't worry about it. 2 lines more have to write. Yeah.
Sir,
I will
line
write for you.
63 will be.
I will come to you and write the code. 2 lines more I will write for you. So is there something
Sir,
wrong with
line-
this approach?
It
Yes.
will wait for the function to end.
And so
And so asynchronous is not happening. It is working like
Correct.
synchronous.
Correct. That is the big difference. This approach is what you use when you call synchronous code, wherein you are waiting for that function to get over. But this code that we are calling is asynchronous, meaning the function is running on a separate thread. That means you cannot be waiting for that function to get over. It's not going to wait for you here. It's going to go on to the next line and the next line and the next line. So how can you get the return value? Because you don't know whether the function has got over or not. When can you get the return value from the function? Only after it finishes. But it cannot keep waiting for that function to finish. So this approach is wrong. This approach is wrong. We cannot get the return value here. We can't get it here. Are we getting this, everybody? Because you're saying that the function is running on a separate thread. And how to get the return value now? You can't get the return value here. Earlier, why didn't we face the problem? Earlier, why didn't we face the problem? In my examples earlier, I didn't talk about this. Why not?
Void return.
Because my function had a void return value. But now you have to think differently. Are we clear on this, everybody? Now you have to think differently. So I'll give you another parallel example. Let's say I tell Shubham, you're the first person I can see here, so I've taken your name. I tell Shubham, my lecture is going on. Okay, let's assume we are physically sitting in one lecture room, wherever, Juhu, Kharghar, wherever. So I tell Shubham, can you please get me a book from the library? Can you just get that book and return it to me? So Shubham's job now is to do what? To go to the library, get the book and return me the book. If I was doing this in a synchronous manner, when Shubham goes to the library, I will wait for Shubham to return, give me the book, and then I will continue with my lecture. So if we were doing this in a synchronous manner, I will wait for Shubham to come back and give me the book, and only then I'll carry on with my lecture. But if I'm doing this in an asynchronous manner, so when Shubham goes to get the book, I will not wait for Shubham. I will continue with my lecture. So there is a possibility that I might finish my lecture before Shubham returns. I might go on to the next part of my lecture. Now the question is, how do I get the book that Shubham is returning to me? How does Shubham, because I might go away from that lecture room. So how does Shubham return that book to me? What Shubham says is that, sir, I will bring back the book. I will keep it at the reception. And I will give you a call saying I have brought back the book. Now you go and take the book from the reception whenever you want. Are you getting this? Why is this? Because Shubham might have gone very far away to get the book. he might take a lot of time to get the book back. Or if I send him out, he goes out, suddenly forgets that he has to get the book. He starts looking around, sees something interesting, goes there. So Shubham says, what, sir, I will get you a book back. But when I get it back, I will keep it at the reception. And I will call you saying that what, the book is available. Now it's there. Now you go and take it from the reception whenever you want. So this is the approach that we have to follow in an asynchronous code. In an async code, this is the approach that we'll have to follow. So what is the, if you talk technically, what is the approach that you'll have to follow? You have to use what is known as a callback function. You have to use a callback function. A callback function would be a function that will be called after your original code is over. What function are we calling here? What function are we calling here with begin invoke? What are we calling?
Display.
Display. So when display is over, it will call the callback function. We call the callback function. So I don't care when display gets over. How do I know display is over? How do I know that display is over?
By callback.
Whenever the callback function is called, I know that the display function is over. And in the callback function, what would I do? What code would I write in the callback function? What code would I write in the callback function? Yes. What would I do in the callback function?
Assigning value to the string.
I will read the value that has been returned by display. I will get the return value that display is returned. That is what code I will need to write in the callback function. Are we clear on this, everybody? So let's break this up into two parts. We'll first see how the callback function got called. That's the first part what we'll see. And I think we'll have time only for that today. And then we'll continue the lecture later where we will see how to get the return value from them. So first task at hand, easy task, very easy. What will we do? What will we do? We'll say that when display is over, it should call a callback function. Now, how do you do that? This parameter that you've been ignoring all along, called async callback. That's the one that you'll use. So what is async callback? What is async callback? Look at what async callback is. Can you tell me what async callback is by looking at it? What is this?
Delegate.
It's a delegate. And the delegate will point to what? Will point to what? To a function. What will be the signature of this function? Look at the signature of that function. From here you can make out. Return type is what? Read from here. Delegate. What the return type is? Void. System.async callback. And what is the parameter to that function?
Result. Asynchronous result.
I async result. It's an I async result. So I will have to specify a function in here whose return type is void and whose parameter is of type I async result. This is my callback function. This function will be called after display is over. So let me write down one such function. Function that I'm writing down here is static, right? Void. Why void? Why void? Why void?
So
Why
it is
void?
it is said in the method
That is
signature.
what the signature they are telling me. I have to listen to what .NET tells me. They are telling me, give me a function whose signature return type is void and parameter is of type I async result. So void, whatever, callback function, and whose parameter is of type I async result. God knows what it means. or whatever it is. This function will be called when what? Display is over. And instead of doing this, I will give the function name, saying callback function. That is the function that I want to call. Right? Let's see whether the callback function gets called or not. So console.writeLine, callback function called. Let's just see whether this happens or not. So now when I run this code, what will be the sequence of events that happen? First thing, what will happen? Before, what happens here on o.begin invoke? What will happen? Calls display on a separate thread, but also passing to it a callback function, which says that when display is over, callback function will be called. In the meanwhile, it carries on with the main thread carries on the code for after. So before, after immediately. Then 3 seconds later, display gets called. And then after display is over, the callback function will be called. Let's confirm this. Let's run this and see this. Before, after, 3 seconds later, display. After display, automatically what got called was the callback function. Questions, if any?
Sir, where are we returning the s.to
We are not.
upper?
We are not.
Okay. So
I
why
told you
have
I'll break it up into 2 parts.
okay,
First part, what am I done? I'm showing you that the callback function got called.
right.
Now what do I have to do next? What do I have to do next?
Use of lambda expression.
Read the value from them. That I have not yet gone in. Are we clear on this? All right. Now I wanted to end the session here, but Kaustubh insists, vehemently insists, give me the return value. Unless you give me the return value, I'm not going to have lunch. I am not saying this, Kaustubh is saying this. But I think the majority is outvoting him. So Kaustubh, I'm not going to listen to you this time. All right. I know you're feeling bad about it, but I will not listen to you this particular time. And we're going to stop here for the day. What's pending? What's pending in this? What is the main thing that we have to do? Is read the value from the callback function, which we'll do first thing tomorrow. Are we clear on this? Or can we do this? Can we do this? Let's do this. We'll take a break now. We'll have a lunch break now, no problem. First half an hour of the lab session, I want to continue with the code. Right? Nisha ma'am, are you here? I'm not
We
sure.
can continue right now.
It will not get over in 5 minutes.
Yes, sir. Yeah.
Nisha ma'am, I need first half an hour for the lab session. I will take a class.
Okay.
Then they can move on to their respective labs. So I want to complete this topic today.
Yeah.
Right?
All right, sir. On the session link. Yeah.
Yeah, same session link. So 3 o'clock
Yeah.
we start off and then we do a half an hour and
Complete
then
this. Yeah.
then move into the lab.
Okay. Yes, sir.
All right. So we'll stop here for the day for this session. Continue at 3 with more of this. All right. See you all at 3. Bye for now.
Yes.
And just wait. I have one instruction for you all. All are there over here?
Yes,
Yes,
ma'am.
Yes, ma'am.
Yes, ma'am.
Sharing something with you all. chat box. Please do the needful.